let's have a try at making a nice graphical demonstration that all surds, or rather all square roots of integers, can be constructed by straight edge and compass, i.e. by drawing it with simple tools. And the classic way of demonstrating this is this image called the spiral of Theodorus, which is just running around from all the square roots from 1 to, I think, 200 in this case. Nice. Let's build the thing from scratch. I want to recreate a file I made a while ago and I've used in talking about in maths talks for ages, and I really like it, but I want to make it quicker in Geogebra than I did last time. So what's the image? It's the spiral of Theodorus. So let's just draw this quickly. Imagine you have a 1 by 1 isosceles right angle triangle. We can build it at the origin, doesn't really matter. This length here would be root 2 from Pythagoras' theorem. And the only real key point in the mathematics here is if you've got another right angle triangle off that with a distance 1 there, a right angle there, then that would be the square root of 3. And if you're not sure why, just convince yourself briefly with me. It's a right angle triangle, square the other sides, 1 squared is 1, root 2 squared is 2, add them together to get 3, square root it, get length of the hypotenuse. And you can carry on. And this is the point here, is you can construct any square root you like. Root 4, famously known as 2, but this is root 5, for example. If each of these new sides is 1 and at a right angle to the previous one, so these are all right angles, then I'd get root 6 here, and I can carry on round. It's a prime candidate to have a slider animating how far you carry on round. You've just got to figure out how to build the thing. And I've done this before, and I've used the animation in lots of talks. So here's a file I made earlier. You can see I've got a slider working here. It's just a bit clunky in the way I've built it, and I just want to do it better with the sequence. So I built this in the spreadsheet, and it looks like the way I did it was to define the point 1, 1. That's up there. I can turn the axes on. So I started at 0, 0, put the point 1, 1, which defines the first triangle, and then this is the vector from A1 to the origin, so that point there to the origin. It looks like I've turned it into a unit vector to make sure it's length 1 and rotated it 90 degrees, or pi by 2, around the point A1. So that's made this line here, which I then translate the original point by that vector to get a new point, and then repeat. You can see I rotate that line. No, what have I done? Rotate the unit vector of that line 90 degrees to get it up there, and you can see I just keep doing that. Now this is fine. I quite like this way of doing it, but when you build stuff in the spreadsheet, it's doing quite a lot of processing in the background, and I want to try and build it with just the sequence command, which has got to be possible. I just need to think a little bit live with you about how to do this. So let's pop back to a clean Geogebra file and do a bit of setup. Let's maybe make the point the origin. I think, by the way, if you just call O, if you refer to capital O, it thinks it is the origin. But let's just make sure Geogebra knows what we're talking about. Let's make the origin there. I'm going to make the point A at 1, 1, and in fact, let's draw the triangle, shall we? So polygon O, A, and I should have made a letter for it, but let's just call it 1, 0, and there is the triangle. Maybe I don't want any more labeling of points. Maybe points is fine, but let's just not label the segments. So there's my triangle, and that has the length root 2. And what I want is a slider, let's call it N, running up to 30 to start with, whatever, why not, that builds triangles off it one at a time. And I want to try and do it without using the spreadsheet. It's an obvious candidate for a sequence command, and my initial thinking is to get a sequence of the points that go around it and then just build the polygons on that network of points, because it's always going to have one of the corners at O, and then the last 2 points in the list of other points is going to be where you build the rest of the triangle. But to do that, I think I need to figure out how the angles work, and this is not too hard, right? So we could just scribble on Geogebra to get a handle on this. If you hadn't realized it, Geogebra has a pen tool in here. It's not the greatest pen software, but it's fine. So if I just want to draw that there, not accurately, that's 1 and that's root 3. And then it would go like this, that's 1 and that's root 4. I dare say I'm not drawing this to scale. But at each point, if I want to make these list of points that are going around here, let's do one more, root 5 there. Then in polar coordinates, they're going to be dead easy, because there's always going to be a radius of root n, whatever n happens to be got up to. The only difficult bit is what angle it's come round from the origin line or from the positive x-axis, and that's going to be the sum of a bunch of these triangles. But actually each triangle is not a difficult angle. If that's theta in there, for example, that theta is arctan 1 over root 3, because tan theta is 1 over root 3. So I think we can do this. Let me try and summarize. I'm going to delete all these pen lines. Let's just get the arrow tool back. And I'm going to do a sequence. And this is going to be a complicated sequence. It's going to be the engine behind everything here. So it's a sequence of points. So let's make it a point. I'm going to put a semicolon between the two parts of the point, because I want this to be a polar point with a radius and an angle. And the radius, I want it to be the square root of some number k. And I'm going to let k run from 1 up to n. So I've got k as a dummy variable, and my slider n controls the last point in the list. That's the radius. The angle is the tricky bit here. I want it to be the sum of all the arctans that we just drew. And there is a sum command, which basically exactly acts like the sigma notation. It's in fact very like the sequence command. It's just, instead of creating the sequence, it's just going to sum it up. Instead of making the sequence and then having to sum that list, we're just diving straight with the sum. So I want the sum of the arctans, and it'll be 1 over the square root of k. Have I got this right? It's possible I've got a plus an off by 1 error. Maybe I want the radius to be k plus 1 and have the sum of all the other ones up to there. And I've got another dummy variable, so actually I'm going to use a different letter p, because I want this sum to have a dummy variable. The sum of the arctans, let's just close the square root, close the arctan, fine. And that little sum is going to run p from 1 to k. And then I want k to run from 1 to n. I think it's done it, which is a little bit of a relief. Doesn't normally happen first try. Let's just crank up n. Look, it's making some dots which feel like they're going in a spiral, and when n is 1, it's got that first point. Okay. If we have problems, if this is not making what we want it to make, we'll find that in a minute. Let us draw the triangles. Now, in order to draw a triangle, I need to specify 3 points. Again, I'm going to do a sequence. It's probably going to be a zip command. I'm probably going to run through the sequence of dots I've already got, and the zip command is a good way to do that. The catch is I want probably the last 2 points. I want it to run through pairs of points in the list, and that's quite awkward. You can use the element command with a sequence, but actually the zip command's really easy. Just run through several sequences. What I'm actually going to do, I think, is make another sequence, which is just drops the first one in this list. You can see this list has got several points in. If I drop the first one, I'll have 2 lists offset by 1, and then I can grab a point from the first point from one list and the first point from another list, and they'll be the offset ones. Let's see what I mean. There's a useful command called last. There's also one called first, by the way, which takes the last number of elements from a list. Let's get the last n-1 elements. I think it's going to be, I mean, if you're not sure how long the list is, you can just say the length of L1 minus 1. That feels like a, I think it's pretty, I'm pretty sure the length of L1 is going to be n by the way I've built it. And lo and behold, that is the same list. You can see these numbers matching except for the first one. And that's good because I can now do a zip command and just join together a bunch of polygons which have the points O, and then we need dummy variables. Let's use capital P and capital Q, with P coming from the first list, L1, and Q coming from the same list but offset by 1, which is now called L2. In theory, this has made the triangles, and that should scale with n. There we go. Essentially, the work is done. The clever bits here, I think, making a sequence with the sum command of the arctans and using the zip command to join them together. One way of doing this is, like I've done, is to make a copy of the first list without the first element and use that in the zip. There are other ways of doing it. This is nice though. I think it's doing what it should. Let's just check how long is that line. I'm just going to draw a segment from O to that point. 1.71. Oh, I missed it slightly. Let's do it properly. Is it going to lock onto there? Yeah, 1.73, and just in case you're not sure, square root 3 is 1.73. So I'm happy that that is doing what it should. It would be nice to display the text, and actually there's a useful sort of convenience with the commands for text in Geogebra that's worth getting to know. So let's have a play with that. But essentially our work is done. We can prettify it in a minute. Let's do that at the end. Hey, but I mean, while we're at it, should we just see how far this will crank up? Should we get up to 200, do you think? The problem with this is that Geogebra's having to calculate 2 or 3 lists in this case, which are then going to go up to 200 elements. I think it'll be fine. Let's zoom out and see what happens. I could just animate it, couldn't I? Should we just go straight with the animation? Yeah, there we go. So famously, Theodorus stopped at 17 because that's where it starts. It's the last length before it starts overlapping. But this is coping, going up to 200. Nice facts here is that because these are all to do with irrational numbers, none of those lengths ever overlap. Those hypotenuses never end up in the same place because these numbers are irrational, or at least almost all of them are, except for the square numbers, square roots. Okay, I said we were going to work on the text. Let's work on the text. Enough of this animation. Let's keep it down to a manageable size. I'd like the text for each length to appear roughly in the middle of its line, but we're going to have some offsetting issues. Let's just get it happening first. So the text command I have an issue with here because I can't show you on the screen. I'm capturing all the autocomplete things. If you're in any doubt, by the way, you can always pop into the help things over here. Let's find in text the text command, and you can see what the command sort of protocol is. You can see there's a lot of options. So you do text for an object, it just turns it into text, and you can drag it around. You can ask it to substitute in the variables. If you include a letter of an object that's in Geogebra, do you want it to be that letter, or do you want it to be the value of that letter? True or false there. You can put it at a point. You can put it at a point with a LaTeX formula that makes it look nice mathematically. And then you've got some, these are things I haven't seen until recently, some horizontal alignment and vertical alignment. That's really useful for making the text appear kind of at the point in the position you want it to. But it does mean our autocomplete has gone a bit crazy. So bear with me here. I'm gonna just choose a basic text command. Let's choose that one. And you can see that it wants an object first of all, and then a point to put it at, and then I want substitution of variables, which I presumably do want because I want it to have numbers in, and I want it to look like LaTeX because I want to have square roots and looking nice. But I also want a sequence of these things. So let's go to the front of the text command and make a sequence of these things, and after that text command we'll have to finish off the sequence bit. So I'll just leave a little ... so I can recognize I need to finish that up. So a sequence of text, and the text are going to be I want this to be LaTeX, so it'll understand LaTeX command if I do /square root and then open the curly brace. I'm going to close the quotes, and if you then just put a number in, it will put that number in. And let's have, this is in a sequence, let's have k being my dummy variable. Do I want k plus 1? Yeah, because the first one I want to print is root 2, so if I run from 1 to n, it's going to start with the root 2, that's fine. So k plus 1, I might put that in brackets to make sure it does that. Otherwise it might think that plus is an append command or something. I'm not entirely convinced I know what's going on, but let's then in the LaTeX command close the curly brace. That looks horrendous. If you're not used to LaTeX, then that will look confusing, and don't stress about it. You could just type some words in here if you didn't want to worry about the LaTeX. At the point, right, I'm going to use the midpoint command. It's going to ask for a couple of points for me, so it's always going to be the midpoint from O to this dummy variable P. I don't want a sequence here. What I want is a zip command, don't I? Yeah, let's do a zip because I want to grab the P from a list. So zip all of that together. We'll sort that out in a bit. I'm still in the text command here though, so let's have the substitution of variables. Yes, true. I want it to be LaTeX true, and there's a couple of other optional parameters to do the alignment. We'll sort that out in a bit. Now finally, in the zip command, I want it to grab P from the list of points, which I think was called L1. I need to tell it where to get K from. Now if it was a sequence command, that's nice. That's K is just K. If it was a sequence command, it would be doing sequence. This is a zip command, so it needs to grab K from a list, but that's dead easy. We'll just make a list that runs from 1 to n. So now it's grabbing, and it looks like it's doing what I wanted. Let's just hit return and get it locked in and check things scale. Nice. Okay, so there's some alignment issues. It's not clear which bit's referring to which bit. It does change when I zoom in. It's better when I zoom in, but if I zoom out to see more, it's not great. And maybe when we start overlapping, this is a mess. So let's deal with some alignment. First of all, I don't think I want it in the midpoint because these things are going to start overlapping a lot. Let's go like, I don't know, almost 3/4 away along those segments. That's easy enough. Let's go back to this command then. Instead of locating it at the midpoint, let's do the midpoint times 1.5. So go half as much again. Yeah, I think I can just do 1.5 times that. Nice, okay. Now, if I put those points visible, you would see, I think, that the text is being written to the right of the points I specify. And I think that's where this new alignment command can help you. I had to go and look up thing, but there's 2 more arguments in the text command, a horizontal and a vertical. And it's going -1, 0, 1 for things like left, center, right, or left, center, right, depending on whether you're looking at the camera or I'm looking at the camera, whatever. And vertical, I think it's below on it above. I think I just want them both centered, so I'm going to put 0, 0 there and see what happens. And it has moved them. That would be more obvious if we'd had those points displaying, but I think that's already better. And let's just do some tidying up. I don't think we need the grid. I don't think we need the axes. I don't think I need B and A visible, or O for that matter. So let's just turn up. I don't know why B's gone down there. Strange. And maybe I can pop out the algebra window. So when I pop it out, by the way, this is now draggable. I can drag this off screen. And now if I save this, for example, up to Geogebra Tube, I've got a cleaner image. And it won't have these toolbars if I upload it to the Geogebra resources page. Let's just check this doing what it should. So when I get to n equals 16, it has done 17th root. And you see that's where it starts overlapping if you go beyond that. And all I'm going to do now, I think, I'll leave the algebra window floating here. I quite often work with the algebra window in a separate window so that when I upload it, it's cleaner. I'm going to turn off the points. I've got 2 versions of those points, so let's just turn them both off. And now it's just got the clean polygons. I think we need to make the polygons. Let's go with a black and white theme. Let's make the polygons, which are there. The shortcut is the graphics here. Let's make them black. And then we get a little sort of grey version of them. Notice the first one is different. So let's just pull up the algebra window again. I'll pop this back in for now so you can see what's going on. The first one was that triangle. Let's make that black as well. If you select both things, you can change the properties together. And then anything you choose here will be adjusted together. And we need the text maybe to be a little bit more obvious. So this is the text. I could make the... Oh, that's interesting. Why is that happening? Looks like the background of the... Oh no, it's sorted itself out now. I think that new alignment thing is an interesting addition. It's really helpful, but it's clearly not quite doing what I wanted. I've got some layering issues. Clearly T1 is above it. If you've never noticed, there is a layer command in the advanced. Layer 0. Why is that? So why the text is clearly on a different layer. Let's make layer 1. Did that weird offset again. Anyway, that now layer is above the other one, so you can see all of those. I don't like that yellow. Let's get rid of that. Let's make it clean again. But let's make the text, you know, so bold. I can make it large. Yuck. The text controls are somewhat limited, and it sometimes is pretty frustrating. That's not too bad. I think maybe what we need to do is make the background dark to make this look better. Background color, let's go dark grey. Now it's a bad choice of colours for my triangle, so maybe let's go back to the triangles. That's those 2. Maybe make them white, that would be better. Okay, I've also got an issue with my slider. Let's just deal with that colour. Let's make that white as well. But now I think things are looking quite clean. I've got a root 2 length here. It looks slightly odd where I put it, but that is 3/4 of the way along the thing. And if I start increasing this, you can see you get root 3, root 4, root 5. And you very quickly need to zoom out. But it's dead easy to interact with this. And in fact, should we just let it animate? These numbers are way too big now. Let's make them smaller. Extra small, look at that. And animate that. Maybe this is where we finish. Is it going to get all the way to 200? It does slow down a little bit. Yay, it got there, and it's bouncing back now. Cool, there's the spiral of Theodorus then. We've done it without using the spreadsheet, we've done it using the sequence and zip commands, and I think it is a good demo of those two commands, as well as the fact that you can do a sum command, which actually is what we're used to as mathematicians seeing in sigma notation. Bit of fun. There's also some nice things about the spiral of Theodorus. Apparently Archimedes used it to square the circle, famously impossible in plane geometry, but he used the Archimedean spiral, which is kind of what this is approximating, to do that. That's for another day. I hope you've enjoyed this. Another video coming soon. See you next time.